Serverless computing. Serverless computing is a cloud computing execution model in which the cloud provider allocates machine resources on demand. An architecture where code execution is fully managed by a cloud provider. Instead of the traditional method of developing an application and deploying them on servers, it means developers don't have to worry about managing, provisioning, and maintaining servers when deploying code. Serverless computing does not hold resources in volatile memory. The pricing is based on the actual amount of resources consumed by an application. Are there servers in serverless computing? Perhaps the most biggest controversy associated with the serverless computing is not around its value use case, it's around its name. There are most definitely servers in serverless computing. The term serverless persists because it describes the customer's experience of servers. They are essentially invisible because the customer does not see them, manage them, or interact with them in any way. These are the current platforms for serverless. Some of them: IBM Cloud Functions, Red Hat, Google Functions, Open Lambda, AWS Lambda, etc. Serverless vendors. The modern age of serverless computing began with the launch of AWS Lambda, a platform based on Amazon Cloud Service in 2014. Microsoft followed suit with Azure Function in 2016. Google Cloud Function, which had been in beta since 2017, finally reached production status in July 2018. Among all of these serverless computing platforms, AWS Lambda is the most prominent and obviously has had the most time to evolve and mature. And next one, serverless frameworks. Serverless frameworks are free open source framework for coding. It builds, compiles, and packages code for serverless implementation. It then will deploy it to the cloud. Developers use serverless frameworks to simplify and speed the coding process for their teams. It also makes scaling easier across the developers and helps to decrease configuration time. A couple of leading serverless frameworks are AWS Serverless Application Model SAM and Command Line Interface CLI. And serverless stacks. These are the different components needed to build a serverless application. Stack consists of programming language that you are going to write the code in, an application framework that provide a structure for your code, also provide a set of triggers that the platform will understand and use initiate code execution. Serverless offline. There are ways to run serverless code offline on your own local hardware. For instance, the AWS SAM provide a local feature that allow you to test Lambda code offline. If you are using the serverless application framework, serverless offline plug in that lets you run code locally. Next one, serverless runtimes. Serverless vendors offer compute runtime, also known as function as service platforms, which execute application logic but do not store data. Common language supported by serverless runtime are Java, Python, and PHP. Generally, the function run under isolation boundaries such as Linux containers. Serverless runtime lets you build, run, and manage serverless applications that extend your digital core and can react to the latest business changes. Serverless databases. These systems extend the serverless execution model to the RDBMS, eliminating the need to provision or scale virtualized or physical database hardware. Nutanix offer a solution named Era, which turn an extinct RDBMS such as Oracle, MariaDB, PostgreSQL, Microsoft SQL servers into a serverless service. Amazon Aurora offer a serverless version of its databases based on MySQL and PostgreSQL, providing on-demand auto-scaling configuration. And next one, Firebase, owned by Google, includes a hierarchical database and is available via fixed and pay-as-you-go plans. Serverless application patterns. Developers build serverless applications using a variety of applications patterns to meet specific requirement and business needs. And one of them are serverless API gateway. A serverless API gateway is centralized, fully managed entry point to serverless backend service. It enables developers to publish, manage, secure, and analyze APIs at a global scale. Serverless Kubernetes. Developers bring their own containers to fully managed Kubernetes clusters that can automatically scale up and down with sudden changes in traffic on spiky workloads. Serverless functions. Serverless functions accelerate development by using an event-driven model with the triggers that automatically execute code to respond to event and binding to seamlessly integrated additional services. A serverless application environment. With a serverless application environment, both the backend and front end are hosted on fully managed services that handle scaling, security, and compliance requirement. Advantages of serverless computing. Cost effective. Serverless computing is generally very cost effective, and traditional cloud providers of backend services often result in the user paying for unused space or idle CPU time. Simplified scalability. Next one, simplified scalability. Developers using serverless architecture don't have to worry about policies to scale up their code. The serverless vendor handles all of the scaling on demand. Simplified backend code. With FAS, developers can create simple functions that independently perform a single purpose, like making an API call. And next one, quicker turnaround. Serverless architecture can significantly cut time to market instead of needing a complicated deploy process to roll out bug fixed and new features. Developers can add and modify code on a piecemeal basis. And next one, um, disadvantages of serverless computing. Performance. Infrequently used serverless code may suffer from greater response latency than code that is continuously running on a dedicated server, virtual machine, or container. This is because, unlike with auto-scaling, the cloud provider typically spins down the serverless code completely when not in use. This means that if the runtime, for example the Java runtime, requires a significant amount of time to start up, it will create additional latency. Resource limits. Serverless computing is not suited to computing workloads such as high performance computing because of the resource limits imposed by cloud providers. Privacy. Many serverless function environments are based on proprietary basic public cloud environments. Here some privacy implications have to be considered, such as shared resources and access by external employees, vendor lock-in. Serverless computing is provided as a third-party services. Applications and software that run in the serverless environment are by default locked to a specific cloud vendor. Therefore, serverless can cause multiple issues during migration. Thank you.